Hi everybody, my name is Kate Berry from the University of Texas at Austin, and today I'm going to talk to you about difference problems. We see difference problems in all three of our interventions. In our individual intervention with total difference and change schemas, our small group intervention with total difference, change, and equal group schemas, and our third grade STAR test prep intervention with total difference, change, and equal group schemas. In all three of our interventions, we have 5 different components: Math Fact flashcards, Equation Quest, Buccaneer problems, Ship Shape sorting, and our Jolly Roger review. We see our difference problems primarily during our Buccaneer problems, Ship Shape sorting, and Jolly Roger review activities. We see difference problems during the Buccaneer problems when students solve difference word problems using our difference schema. We see difference problems in Ship Shape sorting when students sort cards belonging to the difference schema. And we see difference problems in our Jolly Roger review, which is our independent practice activity, when students solve word problems that are difference problems. Primarily though, we use difference problems in our Buccaneer problems component of our intervention. So today, that's what we're going to be targeting. To solve difference problems, you'll need the following materials: our run poster, our difference poster, our Buccaneer problem worksheet, and a pencil. As students become more comfortable and fluent with solving these word problems, teachers may choose to fade the 2 posters so that students can work to solve the problems without the help of these aids. We have 4 different schemas in our interventions. We talk about total, difference, change, and equal group schemas. Today, we're going to primarily focus on difference schemas. For each of our 4 schemas, we teach students to gesture. We find that gesturing helps students to recall the information as they're solving the word problems. For our difference problems, we use the following gesture. We have an amount that's greater, amount that's less, and we're comparing the 2 amounts for a difference. We teach students to put one hand above their forehead as if they're looking out, and one hand below their chin right here at their chest. And we teach them to move their hands back and forth to show the difference. So if we did that all together, it would look like this. I have an amount that's greater, an amount that's less, and I'm comparing the 2 amounts for a difference. Today we're going to talk about the 3 different types of difference problems students see or encounter during our Buccaneer problems. We're first going to look at a difference problem where the difference is missing. Then we're going to look at a difference problem where the amount that's greater is missing. And finally, we're going to look at a difference problem where the amount that's less is missing. For all of our difference problems, students follow the steps on the difference poster. And before we get into our 3 example types, I'm going to go over our difference poster steps. Step 1 is write G minus L is the same as D. G stands for the amount that's greater, L stands for the amount that's less, and D stands for the amount that's the difference between the 2 amounts. What's important to note here is that we don't want students using words like bigger or smaller because those words are inaccurate. Those words talk about quantities. Here we're focused on comparison. So step 1 is to write G minus L equals D. The amount that's greater minus the amount that's less is the same as the difference. Step 2 is bracket. You'll see right here these brackets. Bracket the comparison and label G and L. Our comparison is a sentence that helps students because it's a sentence that tells them that we have an amount that's greater, an amount that's less, and we're comparing. We teach students to identify the compare word. We teach students that the compare words are words like more, fewer, less, and ER words that signify a comparison, such as taller, faster, or stronger. Students bracket the comparison and they label the G, the amount that's greater, and the L, which is the amount that's less. As you'll see when I demonstrate in the problems, we want students to label the G and the L above the words and not the numbers. G again stands for the amount that's greater, L stands for the amount that's less. Step 3 is find D. D stands for the difference between the 2 amounts. So students identify the number, or if the number is missing, put an X where the D is. Step 4 is to find G and L. So students, after they've labeled G and L in step 2 above the words, will figure out what the corresponding numbers are, and they will write G and L, the amount that's greater and the amount that's less, and they'll put numbers for those two amounts. Step 5 is to write the signs. In a difference problem, the signs are always minus and equals, or what we like to say minus and the same as. Step 6 is to simply find x or solve x. And lastly, we have our little parrot asking if our answer makes sense. We know in a difference problem that the answer makes sense if the amount that's greater is bigger than the amount that's less and bigger than the difference. Now let's take a look at a problem. First, I'm going to talk to you about a problem where the difference is missing. We're first going to solve a problem where the difference is missing. We teach students every time they see a word problem that they need to run through the problem. So I'm going to run through the problem with you, and then I'm going to follow the different steps. The first thing we need to look for is a table or a graph. We do not see a table or a graph in this problem. If we did, we would underline it and label what the numbers are. We would number the graph. But here we don't see that, so we can run through the problem. Here I wrote R-U-N to help me remember to run through the problem. The R stands for read the problem. So let's read the problem. It says, 8 dogs are running in the park. 6 cats are eating in the park. 4 dogs are sleeping in the grass. How many more dogs are running than sleeping? So I've read the problem, so I'm going to put a check mark next to my R. The next step is U. U stands for underline the label and cross out irrelevant information. I always look for my label in the question sentence. So let's read the question sentence. It says, how many more dogs are running than sleeping? The question is asking me about dogs, so what I'm going to do is underline dogs because that's my label. Now I have to check for irrelevant information. I want to make sure that all of my numbers are talking about dogs. So let's take a look. Our first number, 8, that's about dogs, so we need that. Let's scan across. Our second number is 6. 6 is about cats. We don't care about cats. We only care about dogs. So I'm going to cross out this whole second sentence. 6 cats are eating in the park. That's irrelevant information. Those numbers are not about our label. Our next number here is 4 dogs. That's talking about dogs. That's about my label, so I need that information. It is relevant. Okay, I've read the problem. I've underlined the label and checked for relevant information. The N stands for name the problem type. I need to ask myself, are we putting parts together for a total? Are we comparing two amounts for a difference? Or do we have an amount that increases or decreases to a new amount? Here, we're comparing two amounts. We're comparing the dogs that are running and the dogs that are sleeping, and we're trying to find the difference between these two amounts. Because this is a difference problem, I'm going to put a D right here in the corner to let me know that this is a difference problem. Now that I've run through the problem, I can follow my difference poster here as a way to solve it. Okay, so step 1 says write G minus L is the same as D. The amount that's greater minus the amount that's less is the same as the difference. Step 2 says bracket the compare sentence and label G and L. We teach students that the compare sentence is a sentence that has a compare word. We teach students that the compare word is words like more, fewer, less, and ER words. Here, I see the word more. So what I'm going to do is circle more because I know that that's my compare word. And the compare word is the word that's telling us that there's an amount that's greater and there's an amount that's less. So what I'm going to do now is bracket my compare sentence. And now I'm going to label G and L. So when I look at this, I see that there are dogs running and there are dogs sleeping, and I'm comparing the two. There are more dogs running than sleeping, so the dogs that are running is the amount that's greater. So I'm going to put a G above running. Notice that I did not put the G above 8. You always want to label the G and the L above the words and not the numbers, otherwise students may get confused. So I've labeled the G, now I need to label the L. The amount that's less is the dogs that are sleeping. So I'm going to put an L right there to identify the dogs that are sleeping. So I've bracketed the compare sentence, which has my compare word. Again, compare words are words like more, fewer, less, and ER words that indicate that there's an amount that's greater and an amount that's less. I have labeled the G and the L. Step 3 is define the difference. We teach students that if there's a number in front of the compare word, we have the difference. If there's not a number in front of the compare word, the difference is missing. So I look at my compare word more. Do I see a number in front of it? I do not. So I know that more is that the difference is missing. So I'm going to put an X under our D. If there were a number in front of this, I would know that the difference would be a number. And we'll see that in the examples that follow. Step 4 is define G and L. I know that G is the number of dogs that are running. And the number that corresponds with that is 8. So I'm going to put an 8 here. And I'm going to check off my number because I've already used that. Now the amount that's less are the dogs sleeping. I see that the number 4 corresponds with the dog sleeping. So I'm going to put a 4 right there. And I'm going to check off the 4 because I've already used that number. Step 5 is to write the signs. In a difference problem, our signs are always minus and equals or minus and the same as. So I'm going to add that here. Now we teach students to isolate the X or to get the X by itself. So what we want to do for step 6, which is define X, is we draw a line down from the equal sign. That reminds us to balance both of the sides. We circle the X. We see that X already is isolated. It's alone on this side of the equal sign. So all we need to do is subtract 8 minus 4. If students don't know 8 minus 4 in their head, they can use our counting up strategy, which you can reference in another video. I can put the minus number 4 in my fist. 4, 5, 6, 7, 8. The answer is the last number, or the number of fingers I have up, which is 4. So I'm going to write X equals or is the same as 4. But I'm not finished. Every number likes a label. We don't want our numbers to be lonely. We have a number and we have our label. Our label is just what we underline in the question sentence. Here you can see we underline dogs. So dogs is going to be our label. So we have our number and our label. The last thing we need to check is whether our answer makes sense. So we look at this parrot down here and ask, does our answer make sense? We teach students that grumpy G has to be the biggest or else G is going to get really grumpy. So here we look at G. Is 8 bigger than 4? Yes. Is 8 bigger than this 4? Yes. So we know that our answer makes sense and that we've solved the problem. Now that we've solved a problem, let's take a look at an example of student work where the student is solving a problem where the difference is missing. Here we see a graph. The student has numbered the graph. The student has read the problem, underlined the label in the question sentence, which is students. The student also has run through the problem. They've read it, they've underlined the label. They've crossed out irrelevant information. This question says the graph shows the favorite subject of third grade students. How many more students chose math than writing? So the student crossed out reading and science because they're not asking about reading and science. They've crossed out irrelevant information. They've named the problem type. Here you can see this D. The student has identified this as a difference problem because we're comparing the number of students who chose math versus the number of students who chose writing. Here, the student, after the student wrote the D, wrote the difference equation, G minus L equals D. The student then bracketed the compare sentence. How many more? More is our compare word. That's the word that's telling us that we have an amount that's greater and an amount that's less. Remember, more, fewer, less, and ER words are ways that we teach students to identify compare words. They've bracketed the compare sentence. They've labeled the G and the L, the amount that's greater and the amount that's less. And then they've identified that the difference is missing because there's not a number in front of the compare word. The G is the math, so they wrote 22. And the L is the 13. And then they subtracted and correctly regrouped. And then they correctly wrote 9 students. Let's now take a look at a different kind of difference problem. Let's take a look at a difference problem when the amount that is greater is missing. So again, whenever I see a word problem, I always want to run through the problem. We want students to use the same attack strategy whenever they see a word problem. The first thing I need to do before I run through it is check for a table or a graph. I do not see a table or a graph. If I did see a table or a graph, I would make sure to number it. But I don't, so I'm going to run through the problem. To help me remember, I'm going to write R, U, N right here. The R stands for read the problem. Let's read the problem. Bess had a party. She invited 2 fewer boys than girls to the party. She invited 15 boys. How many girls did she invite? I've read the problem, so I'm going to check off that R. The U stands for underline the label and cross out irrelevant information. When I underline the label, I'm going to underline it in the question sentence. The question asks, how many girls did she invite? The question is asking me about girls, so I'm going to underline girls as my label. But I'm not finished with you. I now need to check for irrelevant information. I care about all the numbers that are about my label. My label is girls. Sometimes, though, we have numbers that we need that are not about our label, but that are talking about the same thing. For example, we need boys in this problem. Our label is about girls, but we also need boys. So we want to teach students also that the label is not necessarily always going to be the only numbers that we need. So let's take a look. Our first number is 2, and that talks about boys. We need boys, because if we crossed out 2, we would only have 1 number, okay? And then the 15, we also need boys here. So we don't have any irrelevant information in this problem because we need boys and girls. They're talking about the boys and girls at the party. The N stands for name the problem type. I need to ask myself, am I putting parts together for a total? Am I comparing 2 amounts for a difference? Do I have a starting amount that increases or decreases to a new amount? And in one of our programs, we ask students, do we have groups with an equal number in each group? When I look at this problem, I see that we're comparing. We're comparing the boys and the girls and the boys at the party. So I know this is a difference problem. To help me identify that this is a difference problem, I'm going to put a D right here and circle it. Now I can follow my difference poster here to help me solve the problem. My first step is write G minus L equals D. The amount that's greater minus the amount that's less is the same as the difference. Let's go ahead and do that. Our second step is to bracket the compare sentence and label G and L. We teach students that our compare word identifies that we have an amount that's greater and an amount that's less. We teach students a little fun clap, more, fewer, less, ER words. When I look here, I see the word fewer. That's my compare word, so I'm going to go ahead and circle that. Okay? We've circled fewer, so we know that that is my compare sentence. So I'm going to go ahead and bracket it. She invited 2 fewer boys than girls to the party. Now I'm not finished with step 2. I also need to label G and L. Again, we want students to label the G and the L above the words and not the numbers. Here we have fewer boys, so we know that the boys are the amount that's less. We have more girls, so we know that the girls is the amount that's greater. So I'm going to put an L above boys. And I'm going to put a G above girls. We've labeled the amount that's greater and the amount that's less, and we've bracketed our compare sentence. Step 3 is to find D or the difference. We teach students that if there's a number in front of the compare word, that means we know the difference. I've identified my compare word as fewer, and when I scan my finger to the left, I see the number 2. That lets me know that 2 is my difference. So I'm going to put 2 under the D, and I'm going to check off the 2 to let me know that I've already used that number. Step 4 is to find G and L. We've identified that G is the girls and L is the boys. So now we need to figure out which numbers correspond with boys and which number corresponds with girls. Here, it's asking me how many girls. I don't know how many girls, so that means I need to put an X under G to identify my missing information. Our next amount is boys. Boys is the amount that's less, And I've identified that boys with here is the amount that's less. So here we see that 15 is the number of boys. So I'm going to put 15 here. Step 5 is to write the signs. In a difference problem, the signs are always minus and equals, or what we say minus and the same as. So I'm going to go ahead and add those to our equation. Step 6 is to find x. We teach students to isolate the x. If you want to learn how to isolate the x, you can view and reference our Equation Quest video where we talk more specifically about x and how to isolate the x and how to solve for x in standard and non-standard equations. But for the case of this problem, I'm going to just draw my line down from the equal sign to remind myself to balance both the sides. I'm going to circle the x. X is not isolated or alone. To get the x alone, I'm going to do the opposite of minus 15 so that I can cancel this out. So the opposite of minus 15 is plus 15. Minus 15 and plus 15 equals 0. But what I do to one side, I have to do to the other side. If I add 15 over here, I have to add 15 over here. This all cancels out because this is 0, and now the x is isolated. Now I can solve. 15 plus 2 is 17. If students don't know how to do the math, you can have them follow our counting up steps, where they put the greater number in their fist and say it, and they count up the number that's less. 15, 16, 17. The sum is the last number we say. Here, our sum, our answer, our difference, because we're talking about a difference problem, so our answer is always called the difference, is 17. So I'm going to write my answer, or my difference. X is the same as 17. But that number is lonely. That number needs a label to keep it company. So my number and my label. All I need to do to find my label is to look and see what I underline. Girls is my label. So I'm going to write it here. Now I have my number and my label. Now I need to check and make sure my answer makes sense. If the G is the greater a number, then we know that our answer makes sense. We teach students that grumpy G has to be the biggest. Here, G is 17. 17 is bigger than 15, and 17 is bigger than 2. So I know my answer makes sense. Now we're going to take a look at student work, where the student solved a problem where the amount that's greater is missing. We've just looked at a problem and solved a problem where the amount that's greater is missing. Here we see an example of students solving a difference problem where the amount that's greater is missing. Here, the student read the problem, underlined the label, baseball cards, identified the problem as a difference problem because it says Charlie has 24 more baseball cards than football cards. He has 45 football cards. How many baseball cards does Charlie have? Here we see that we're comparing two amounts. We're comparing Charlie's baseball cards to his football cards. Here you can also see that the student wrote our difference equation, G minus L equals D. The student then bracketed the compare sentence, identified more as the compare word, bracketed the compare sentence, labeled G, it's kind of cut off here, but G above baseball cards and L above football cards. Notice that the G and the L were not placed above the numbers, they were placed above the words. The student identified 24 as the difference because 24 is a number directly in front of the compare word. The student identified that the baseball cards was the amount that's greater. We don't know that number, so the student put an X. The student put the minus 45 because 45 football cards is the amount that's less. Then you can see the student put the minus and same as sign and isolated the X, circled the X, drew a line down from the equal sign. It said minus 45. To get rid of minus 45, we need to plus 45. What we do on this side, we have to do on this side. The student drew a vertical line between the ones and tens column to separate the two. The student correctly added, solved for X, and wrote a number and a label answer. Also, the student checked the work and identified that 69 is greater than 45 and 24, so we know the answer makes sense. We've talked about difference problems where the difference is missing, where the amount that's greater is missing. Students also encounter problems where the amount that's less is missing. So what we're going to do now is we're going to demonstrate, and I'm going to demonstrate and solve a problem for you where the amount that's less is missing in a difference problem. Let's take a look. Here, we see a word problem. Again, we teach students to follow the run attack strategy whenever we see a word problem. It doesn't matter what attack strategy you use, as long as the first step is to read the problem, and as long as you're using the same attack strategy throughout every word problem. So we first, before we even read the problem, want to check for a table or a graph. We do not see a table or a graph. If we did see a table or a graph, we would number it. But we don't, so we can run through the problem. So I'm going to write R-U-N over here. The R stands for read the problem. Let's read the problem. Abby is 5 years older than her brother. If Abby is 16 years old, how old is her brother? So I've read the problem. The U stands for underline the label and cross out irrelevant information. I find the label usually in the question sentence. Here it says, if Abby is 16 years old, how old is her brother? But we know that when we're talking about years and age, we're talking about years older. We're not going to underline old because that's not really what our label would be. Kind of like if we had a problem with money and we saw the word cost, our label would not say cost, it would say dollars. So here we're going to underline years and old because our label is really years old. Now we need to check for irrelevant information. We need to check and make sure all of our numbers are talking about age or years. So let's scan the numbers. Our first number is 5. It's talking about years, so we need that number. Our next number is 16. That's talking about years, so we also need that number. So we do not have any irrelevant information in this problem. All of the numbers in this problem are about our label. Everything is relevant. Now we move to the N. N stands for name the problem type. I need to ask myself, are we putting parts together for a total? Are we comparing two amounts for a difference? Do we have a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Here, I know that we're comparing. We're comparing Abby to her brother. And when we're comparing two amounts for a difference, we know that this is a difference problem. To help me remember that this is a difference problem, I'm going to put a D right here. Students can put a D here, in the corner over here, anywhere near the problem. Now I have run through the problem. Now I'm ready to follow my difference schema steps. I have my poster down here to help prompt me. Our first step is to write the difference equation. The difference equation is G minus L is the same as D. Our step 2 is to bracket the compare sentence and label G and L. Again, our compare sentence is the sentence that has our compare word. And our compare word is the word that is an indication to us that we have an amount that's greater and an amount that's less. Here, we teach students that if we have words like more, fewer, less, or ER words, that we know that those are compare words. It's important to explain to students that words like faster, taller, smaller, smarter, these are compare words, but other words that end in ER, like sister, together, cucumber, these are not compare words because they do not indicate a comparison. We cannot say she is more cucumber than I. We can say she is faster than I, okay? So here, we're going to bracket the compare sentence. More, fewer, less, ER words. I see an ER word. I see the word older. I'm going to circle that because that's an ER word that's telling me that there's a comparison. So I know that older is our compare word, and to figure out the compare sentence, I just bracket the beginning of the sentence all the way to the end of the sentence. So Abby is 5 years older than her brother is our compare sentence. I now need to label G and L. I need to label the amount that's greater above the word and the amount that's less above the word. Here, we're comparing Abby and her brother. I know that Abby is older, so she's going to be the amount that's greater. I see that her brother is younger, so he's going to be the amount that's less. So I'm going to put a G above Abby. And I'm going to put an L above her brother. That's going to remind me that Abby is the amount that's greater and her brother is the amount that's less. Step 3 is to find the difference. If I look in front of the compare word and there's a number, I know that I have the difference. If I look in front of the compare word and I do not see a number, I know that the difference is going to be X because it's our missing value. So let's look back at our compare word, older. Here, I see the number 5 in front of older. So I know that 5 is going to be my difference. I'm going to check that off and write 5 under D. Step 4 is to find the G and the L. We know that Abby is the amount that's greater. Here it says that Abby is 16 years old. So I'm going to put a 16 there, and I'm going to cross off the 16. It's asking me how old her brother is, so I don't know the amount that's less. So I'm going to put an X here. I don't know the amount that's less, so I put an X. Step 5 is to write the signs. In a difference problem, our signs are always minus and the same as, or minus and equals. So I'm going to add those to my equation. Step 6 is to find X. We teach students to find X by isolating the variable. Again, if you want more information about our isolating the X steps, you may view the Equation Quest video. First, I draw a line down from my equal sign to remind me to balance both the sides. Then I'm going to circle the X. Is X isolated by itself on this side of the equal sign? It's not. In fact, there's a minus in front of the X. Whenever there's a minus in front of the X, we teach students that they have to do a plus X on the other side. The X does not like the minus in front of him, so we're going to move him to the other side and cross him out. Then I'm going to rewrite the equation. 16 is the same as 5 plus X. Now I'm going to draw a line down, circle the X. X is not isolated. The 5 is next to him. If it says plus 5, I can get rid of this with a minus 5. Plus 5 and minus 5 is the same as 0. But what I do to one side of the equation, I have to do to the other side. So I'm going to cross this out, draw a line between my 1s and 10s. 6 minus 5 is 1. 1 minus 0 is 1. X is the same as 11. I have my number answer, but we don't want our number to get lonely. The number needs a label. And what did we underline? We underline years old. So I'm going to write that. We have our number and we have our label. The last thing we need to do is check our little parrot down here to see if X makes sense. In a difference problem, the G, what we like to call grumpy G, always has to be the greatest number. Here I see that G is 16. 16 is greater than 11 and 16 is greater than 5, so we know our answer makes sense. I'm going to take a second to erase this board, and then I'm going to show you an example of a student solving a difference problem where the amount that is less is missing. Now that we've demonstrated how to solve a difference problem where the amount that's less is missing, let's take a look at a student's work solving a problem that is a difference problem where the amount that's less is missing. Here the student read the problem. Let's read it together. The grocery store has 22 fewer peaches than apples. If the grocery has 74 apples, how many peaches does the store have? You can see the student underline the label, peaches, in the question sentence because that's what it's asking us about. The student did not find any irrelevant information because all the numbers, even though they're not all talking about peaches, they're both talking about fruits. We're talking about peaches and apples, so we know we need both of those numbers. The student correctly named the problem type as a difference problem, which is identified over here as a D, because we're comparing apples and peaches. The student wrote the difference equation, G minus L is the same as D, identified fewer as a compare word, more, fewer, less, ER words, found fewer, then bracketed the compare sentence, which is the sentence that has the compare word, identified apples as the amount that's greater, and peaches is the amount that's less. Because if it says we have fewer peaches, we know that we have less peaches. Then the student identified D. If we look at our compare word, fewer, we see a number in front of it. That tells us that that number is D. So the student put 22 under D. Then we identified the G as the apples, so 74, and that we didn't know the amount of the peaches. We did know the amount that's less, so that's the X. Here you can see the student isolated the X. The student crossed it out, moved the plus over here, subtracted 22 from both sides for 52 peaches. Number and a label. The student checked the work by identifying that the amount that was greater was the largest. So 74 is greater than both 22 and 52, so we know our answer makes sense. Here is an example of a student working with a tutor or a teacher to solve a difference problem. As you go through and you watch the difference problem, I want you to notice that the student runs through the problem using our word problem attack strategy. The student correctly identifies the problem as a difference problem. The student writes the difference equation, identifies the compare word. The student brackets the compare sentence, labels the G and the L above the corresponding words. The student then identifies the difference, puts the numbers under the G and the L that correspond to the amount that's greater and the amount that's less. Also, the student correctly solves for X by putting a minus and same as sign and solving for X and putting a number and a label answer. You'll also notice during the video that you see both the student and the teacher gesturing.
All right, Mia. Let's look at Buccaneer problem C. What's R?
Read the problem.
You got it. Do you see a table error graph?
No, at the back I do.
You do on the back. You're right. What would you do if that graph went with this problem?
Label.
You're right. Okay, so let's run through the problem. R is?
Read the problem.
Do you want to read or would you like me to?
I want you to read.
Okay, ready? Bess had a party. She invited 2 fewer boys than girls to the party. She invited 15 boys. How many girls did she invite? Okay, after that, remember there's 2 steps on the next one. You have to put, good. Why'd you circle the number also?
Because he told me to.
Why though?
Because it's a part of the difference.
How do you know it's the difference? Because it's with the?
It's with the compare word.
Yeah, freeze, ready? What do you have to do after you circle that? You have to put
Brackets
around the
around the compare word.
compare.
Sentence.
Yeah, brackets around the compare sentence and label. Yeah, we have 2 parts, right? What are we comparing? Pickles and avocados?
Girls.
And?
Boys.
Good. So we have to label girls and boys. One is going to be the amount that's greater and the other is going to be the amount that's less. Let's read the compare sentence. Ready?
She invited 2 fewer boys than girls to the party.
Good. So who is the amount that's greater?
Girls.
Yeah, so what should you write over girls? Beautiful job. And then what goes over boys?
X.
If girls is the amount that's greater, boys is the amount that's?
Less.
Yeah, so let's put it over here. Nice job. Okay, now go. You got this. So you found the differences 2. What should we do to that 2? Yeah, nice job. Okay, now we need to find G and L. Do we know how many girls? So what should that be? You got it. Do we know how many boys? What's the line remind you to do?
Balance.
Good job. That was perfect. Nice job.
Thank you so much for taking the time to view our video on difference problems that are featured in all 3 of our Pirate Math Equation Quest interventions. I'd like to take this opportunity to thank IES, the University of Texas at Austin, and the Meadows Center for preventing educational risk. Without their support, this work would not be possible. Thank you.